Alright class, the first topic we're talking about are law of sines and cosines. Law of sines, you can use that on any triangle that has two angles and a side, so AAS or ASA. Or there's a special case that we're going to talk about in the next notes when it's SSA, so when the angle is not between the two sides and you have two sides and an angle. Law of cosines we use when we have all three sides, or if we have two sides and the included angle, so that's the difference there. So we're going to just do this, round the sides to the nearest thousandth, angles to the nearest minute. So solve each triangle. So we have triangle ABC, where C is 103, B is 28, and little b is 26. Now I always make charts with this. You don't have to. It helps organize my thoughts. And again, if you need to catch up, you can always pause the video. So I know that angle A we don't know yet, but you guys should actually be able to get that really shortly. So this would definitely be a law of sines because we have more than one angle. The first thing you should be able to find is angle A. Angle A is just 180 minus the other two angles. And that is because triangles add up to 180. The angles in a triangle add up to 180. So this is 49 degrees. Alright, now I can use law of sines to find the other pieces of information. So I can say the sine of 28 degrees over 26 is equal to, if I'm looking for side C, I can say sine of 103 over C. Cross multiply and divide. So you get 20C is equal to 26 sine of 103 and then divide by sine of 28. That's what happens when you solve that. And then when you type all that in, make sure you're in degree mode. You get about 53.962 feet. So 53.962 feet. And we have to do the same thing for letter A or side A. Now, when you do this, you still want to use the information for B because that is exact from the problem. So we're going to still use 28 and 26. Now I'm going to use sine of 49 and then put that over little a. Okay? Cross multiply, you get A sine of 28 equals 26 sine of 49. A is equal to this divided by this, which is approximately 41.797 feet. Okay, so again, a quick check. The biggest side should always be across from the biggest angle. That looks good. So all that is the information for this triangle. Okay, let's do number 2. Draw another random triangle where you have A is 12, C is 16, and B is 38. Now, I'm going to do the chart real quick, but again, and here's how you know if it's law of sines and cosines looking at the chart. If you have an angle and side pair, you can use law of sines. However, if you look at this chart, we have little a, so side of A is 12 meters. Little c is 16 meters, and big B is 38 degrees. We can't do law of sines because we don't have an angle that goes across from the side. We have to use law of cosines to find the missing side here. So we're going to set it up looking for little b, so we're going to say b squared is equal to a squared. We're going to use this formula, which is law of cosines. Okay, so now I'm going to put all my numbers in. B squared is equal to 12 squared plus 16 squared minus 2 times 12 times 16 cosine of 38 degrees. So B is approximately the square root of all of that. Did I simplify it a little bit? I just oh, this whole thing becomes 400, this grouping right there, minus whatever that is. So we get B is approximately 9.869 meters. Now, I talked about this in class, but I'm going to talk about it again. To be safe, you can use law of cosines again to find C or A. However, you can use law of sines here. When finding angles, you can use law of sines for only the two smaller angles. And this is to find them, for only finding the two smaller angles. Because the calculator sine inverse does not give you anything greater than 90. So if you try to do it with angle C, for instance, if you try to find angle C right now with law of sines, it won't work, because unless it's an acute angle. But if it's an obtuse angle, it won't work. So we're going to use law of sines to find angle A. Because we know angle A has to be acute, because it is the second angle in the triangle. So multiply both sides by 12. Now remember, when you're looking for an angle, you sine inverse both sides. And you get angle A is approximately, remember, well, I could, I'm just going to write these down. You get 48 degrees, 29 minutes. And then once you have the second angle, you can find angle C by subtracting 180 minus the two other angles. And you get 93 degrees and 32 minutes. So it's a good thing that we did not use law of sines to find angle C, because there's no way we could have had an obtuse angle from that. So those are all the pieces for this triangle. Now this one here is very similar to the last one, except for now we do not have an angle. We have all three sides. So side B is 17, side A is 13, side C is 23. If you like using law of sines like I was talking about, we only use law of sines when it's the smaller angles, which means that I have to use law of cosines first, because I have nothing that matches up with an angle. But when you are using law of cosines, it's good to find the obtuse angle, or the biggest angle if possible. So find the largest angle using law of cosines if you're finding an angle. Okay, so in this case the largest angle would be C. So my setup will be C squared equals A squared plus B squared minus 2AB cosine of C. So now I'm going to start plugging my values in. C is 23 squared equals 13 squared plus 17 squared minus 2 times 13 times 17 cosine of C. Now be careful here. A lot of people make this mistake. They try to combine all these numbers when they shouldn't. So you get 529 is equal to, if you add these two together, you can combine those, you get 458 minus this stuff here becomes 442 cosine C. Again, you cannot subtract the 458 and the 442. You have to move the 458 this way. So when you subtract, you get 71 is equal to negative 442 cosine of C. You get 71 negative over 442 is equal to cosine of C. And then we can cosine inverse both sides. So we get C is approximately 99 degrees and 15 minutes. And again, this is very helpful for us because we now have the obtuse angle, which means that to get the other two, we can now use law of sines. So I'll use law of sines to find angle B. So I have sine of 99 degrees 15 minutes over 23 equals the sine of B over 17. Multiply by 17. And you're left with that equals sine of B. And then we sine inverse to get our angle. And we get angle B is approximately 46 degrees 50 minutes, depending on how you round it. So if I go up to the calculator or the chart, and then again angle A is 180 minus that, and minus the 46. Well, that's what I just found. And minus the 99. So you get angle A turns out to be 33 degrees 55 minutes. Okay, so that's how you solve that one. Again, if you're using law of cosines, or if you're trying to find an angle with law of cosines, you just find the biggest one, and then you can use law of sines for the rest of the problem. All right, we have a balloon. An observer there and a there. We need to find the distance from A to the bottom of the balloon. So this looks like, well, we have two angles. Whenever you have two angles of the triangle, we can get the third. So if you do 180 minus 28 degrees 18 minutes and 37 degrees 40 minutes, you get this angle is 114 degrees 2 minutes. Now I can use law of sines because I have that angle that side and I want this over here. So I have that angle on that side. So sine of 114 degrees 2 minutes over 2.32 miles, not that that matters at this stage right here, equals sine of 37 degrees 40 minutes, because that's what the x is across from, over x. So you cross multiply, you get x is equal to these two things multiplied all over sine of 114. Okay? Then you type all that in, make sure you're in the correct mode, and you get x is approximately 1.552 miles. Okay. All right, so next thing they say is, what is the height of the balloon? So this is actually going back to SOHCAHTOA. Heights are always perpendicular to the ground. Now, a lot of people make the mistake where they make both these sides the same. They are not. It did not come from straight down the middle. However, we do know that this, we want to know the height here, we'll call that y, and we know this side here and we know this angle. So since we have a right triangle, we can use SOHCAHTOA and say that this is sine, because it's opposite, of this angle is equal to y over 1.552. So we get y is equal to 0.736 miles. So that's how the height of the balloon right now. Okay, when you multiply 1.552. So that's just using some of your laws of sines and cosines.